Dear students, welcome to NS Online Math classes. Our today's topic is solving of logarithmic inequalities with logarithmic and integer terms. The inequality will be containing both logarithmic and integer terms. So without any further delay, let us start with today's session. First of all, let us look at the given question. Find the solution set of x where the inequality is log of x minus 2 to the base 2 is less than or equal to 2. Moving on to the rules part, the first rule says, bring all the log terms to one side and take the integers to the other side of the inequality and simplify both sides so that there is one term on each side of the inequality and the coefficient of the logarithmic term is 1. We are seeing in our given question there is only a single term on the left side and there is a single term on the right hand side of the inequality. So we do not have to do anything related to rule number 1. But in case we have multiple terms, we have to simplify and get a single term on the left side and a single term on the right side. The left hand side will be containing the logarithmic term. The right hand side will be containing the integer term. Okay, and the coefficient of the logarithmic term should be equal to 1. If it is not equal to 1, you have to take the coefficient and make it the power of the argument. Okay, so we move on to the rule number 2. The integer can be written as integer times 1. That is 2 can be written as 2 times 1. And the 1 can be written as log with same base as the other term and the argument will be equal to the base. The integer becomes the power. So let us see what is happening. Okay, so this is, we will be writing 2 as 2 times 1 and in place of 1 we will be writing log with the same base as the other term. The other term is having a base 2. So the base will be 2 and the argument will be equal to the base. So it will be log of 2 to the base 2. So this is log of x minus 2 to the base 2. The left hand side remains as it is and the right hand side is 2 times. In place of 1 we are writing log of 2 to the base 2, which is equal to, now the integer becomes the power. This is the integer, this becomes the coefficient. So this becomes the power of this 2. So we are having log of 2 to the power of 2 to the base 2 or log of 4 to the base 2. Okay. So the inequality is log of x minus 2 to the base 2 is less than or equal to log of 4 to the base 2. Now we are having one logarithmic term on the left hand side and one logarithmic term on the right hand side, both having the same base. Okay. Rule number 3, use the rules of the previous video on logarithmic inequalities to find the solution set. And if you have not gone through the previous video on logarithmic inequalities, I would definitely be asking you to watch my previous video. But okay, in case you are not familiar with the process, I am giving you the process. We are having this inequality where we are having a single logarithmic term on the left side and a single logarithmic term on the right hand side to the same base. Therefore, we can cancel the two logs, or we can rather not equate, but we take the arguments of both the sides with the same inequality. So over here, just to make things simpler, I have just cancelled the two logs. Okay, and we will be taking the arguments and forming the inequality. So it will be x minus 2 is less than or equal to 4. So what is x? The solution set of x is less than or equal to 6. Now we will be plotting this inequality on a number line. So this is, since it is less than or equal to, we are having the filled in circle. Okay, and it is starting from 6 and extending left side. So it is a ray, the right hand side is fixed and it is having an unending left hand side. Another inequality we are having. What is that inequality? That inequality arises from the fact that the argument of a logarithmic term cannot be less than or equal to 0. It has to be greater than 0. So we will be having this condition as well. This should be fulfilled as well. X minus 2 is the argument which cannot be equal to 0 or less than 0. So it has to be greater than 0. I have written it over here because I did not have any space. Do not get confused. So x minus 2 is greater than 0 or x is greater than 2. Because of this restriction that the argument of a logarithmic term cannot be equal to 0 or less than 0, it has to be greater than 0. So we are having in fact two inequalities. We have plotted this inequality on the number line. This will be plotted now. X is greater than 2. And since this one doesn't contain any equality sign, this is a hollow circle, you see. Okay, empty circle. And it is extending right side because it is greater than 2. Starting at 2 and extending towards the right. Now the solution set will be the common part taken from both these rays. Obviously, the two endpoints will be 2 and 6. And the 2 will be having an empty circle or hollow circle and the 6 will be having the filled in circle. So this is the solution set. Every real number lying between these 2 points, and 6 should be included but not 2. This will be the solution set of our given inequality. So we write the answer as x is greater than 2, not equal to, greater than 2, but is less than or equal to 6. Or in set notation form, you can write x belongs to the set of 2, 6, where this is the parenthesis which indicates that 2 cannot be included, but this one gives us this square bracket, gives us the meaning that 6 will be included in the solution set. Okay, so this is our answer for this question. Find the solution set of x. Log of x minus 2 to the base 2 is less than or equal to 2. So students, this brings us to the end of this session. By the way, I am Nilanjana Sanyal, an online math tutor. Please do like, share and subscribe to my channel if you have found this video helpful. Thank you for staying with me till the end. We meet again very soon. Till then, bye.